If we wanted to use software, use technology, we can do this very quickly with StatCrunch. Let me show you how to do that. From My Math Lab or My Stat Lab, we can access StatCrunch through Question Help. We can also access it through this double window here. It's easier to do the double window when we have data. Click on this double window. So we choose Open in Excel, and this is what we get. We get the data set automatically popping up in Excel. See the 17, 21, etc., 17, 21, etc. Actually, I've already saved this spreadsheet as 3.1.29 data. The easiest way to create a histogram in Excel is to use the Data Analysis package. That's under Data. The far right says Data Analysis. Now, it's possible that you don't have this on your Excel. If you don't, that means you haven't loaded the add-in. Each version of Excel loads add-ins slightly differently. This is how you do it on mine. You have to find add-ins. So in this case, if we go to File, Options, you get a screen and there's add-ins. I have checked off Analysis Tool Pack. That's the data analysis package. So if you don't have data analysis appearing in your data menu bar, you need to go find the add-ins option and add in the analysis tool pack. So now that it's added in, I'll go to Data, click on Data Analysis, and there's a choice of routines. Since we want to create a histogram, I click on Histogram. The input range, that's the data we want to use. So I'll highlight this all the way to the end. There are no labels. I want a chart output. Now you might think that this should work just by highlighting the range and having a histogram being drawn, but often it doesn't. Click OK, and this is the histogram I get. Not very good. The first one is the bin to 1. The next one is the bin from 1 to 8.666. Doesn't make sense to have bins that are not whole numbers. So let's try again. What we need to do in Excel is to actually specify the bins. So I need to scan down, and it looks like 26 is the largest number. So it might make sense, thinking of the rule of thumb of 5 to 8 bins, to make the bin boundaries 0, 5, 10, 15, 20, 25, 30. That'll give me a nice number of bins. 2, 4, 6, 7 bins in this case. So if I go back to data analysis, go back to histogram, and for the bin range, I highlight this set of bins. I click OK. Now this is much better. This is 0, this is 1 to 5, 6 to 10, etc. So here is a histogram for our data. Let's see which one of the choices in my stat lab this corresponds to. This histogram starts off with 3 bars of height 1. we see that each bar corresponds to a frequency of 1. So we're looking for one of the choices that begins with heights 1, 1, and 1. Now we're back in my stat lab. Choice A does not start off with heights 1, 1, and 1. It starts off with heights 4, 4, and 4. So choice A does not match. Choice B is also not 1, 1, 1. It looks like it's 0, 0, 1, 2. So choice B doesn't match. Choice C starts off with 2, 1. Heights of 2 and 1. So choice C doesn't match either. So our Excel histogram doesn't match any of the 3 answers given in my stat lab. What happened? Well, this is because Excel does bins in a slightly different way than most everybody else. Let me give you an explanation. Our data set consists of numbers in the 0 to 26 range. A rule of thumb for histograms is that we'd like to have 5 to 8 bins. 5 if the data set is not too large, 8 or even more if we have a large data set, say hundreds or thousands of data items. Here we don't have too many, so let's try for 5 bins. The width here is 26, actually 27. 27 different numbers. So it makes sense to have the first 5, the second 5, and we're going to need altogether 6 groups of 5. That will get us 30 numbers, which is enough to cover the range. What are the first 5 numbers? The first 5 numbers would be 0, 1, 2, 3, and 4. So that would be the first bin. The next 5 would be 5, 6, 7, 8, and 9, etc. We would start at each multiple of 5 and count up 4 more to include 5 numbers. This would seem to be the natural way of doing things, starting at a value and counting upwards. However, this is not how Excel does it. Excel starts at the top and counts downwards. So this first bin, according to Excel, would be the number 4, because Excel uses the largest number in the bin to specify the bin. The second bin would be 9, the third would be 14, etc. We need 24, we need 29. So in Excel, this is how we need to specify the bins, not 0, 5, 10, etc., which are the beginning numbers, but 4, 9, 14, etc., which are the ending numbers. So let's go back and rewrite the bin boundaries. When Excel writes 0, that means 0 is the upper end. So the first bin is just 0. We want it to be 0 to 4. So if we go back to our original, 0 to 4 means 4 is the highest, then 9, 14, 19, 24, 29, and I think that's all we need to go to because 26 is the highest value. So let's go again. Data analysis, histogram. The bin range, we need to specify our revised bins and click OK. Now we have the same bins as my stat lab has. This 4 means 0 to 4. Show you a trick. If you want to make this 0 to 4, you can type in apostrophe 0 to 4, 0 minus 4. And that changes the labels. You could make this apostrophe 5-9, etc. That makes it a little bit prettier. So which one of these looks like our histogram? It's choice C. A 2 and a 1 and a space, and then 3 tall bars. This one, choice B, doesn't have this space in the middle. Choice A has most of the data on the left. So the correct answer is choice C, and we click on C. Final check. Fantastic. The next part. Is this histogram skewed right, skewed left, or symmetric? What do we mean by each of those? Let's scroll down a little bit. What do we mean by skewed left, skewed right, and symmetric? The easiest one to talk about first is symmetric. That means it looks the same from the left and the right. So we have some kind of center here, and it looks symmetric, the same on the left and right. It might be a hump like that. It could be something more unusual, like a hump on the left and the hump on the right. But whatever it is, left and right of center, it looks the same. That's symmetric. So skewed is when it doesn't look the same on the left and right. Skewed left. Skewed left means if we draw a histogram, we have a lot of extra points here on the left. Or one of my professors, when I was taking it, this class said you draw a big line where most of the data are, draw an arrow where the tail goes, skewed left. Skewed right is just the opposite of skewed left. It's when most of the data are here, and then there are numbers trailing off to the right. So here's the biggest frequency, and it trails off extra numbers to the right. So which one is this? It's a little hard to tell. With only 15 numbers, it's not obvious which one of these three it is. 15 numbers is just not a lot of numbers to make a definite conclusion. I would say that it's probably skewed left. This would be my assessment. This would be my guess. Of course, there are not a lot of points to make it definitive. It's not exactly symmetric, although it's not that far from being symmetric, but it's definitely not skewed right. There isn't a set of numbers way out here on the right. So I would guess it's skewed left, although it's not too far from being symmetric. Let's go back to this and choose skewed left. Skewed left. Final check. Yes, skewed left.